Let's start with something most of us never question. The idea that there's a world out there. Something real, something physical, something solid, existing independently of whether or not you're looking at it. That's the assumption behind almost everything we do. You touch a table, it feels solid. You drop a phone, it falls. You look up at the stars, and you assume they're really there. But there's a problem buried inside that assumption. A simple but uncomfortable question. How do you know? Not how do you believe, or what you've been told, or what works in everyday life. How do you know that the thing you're seeing, touching, hearing, is really there, independent of you? You might say, well, I can see it. But that's not reality. That's perception. And the more you look into how perception works, the more disturbing it gets. See, your brain doesn't show you the world. It shows you a model of the world, a guess, a simulation. It takes electrical signals from your eyes, ears, skin, and reconstructs something that makes sense. And the key word there is reconstructs. You don't see the real world. You see a simplified, abstracted version, filtered, interpreted, edited for survival. That's not just philosophy, that's neuroscience. What you experience as color, for example, isn't in the world, it's in your head. Light has no color, it has wavelength. And there's nothing red or blue about these wavelengths in themselves, they're just energy. Color is your brain's translation of certain frequencies of light into a visual code that makes sense to a human being. Other species perceive color differently, or not at all, based on their biology. Even humans can experience color differently due to variations in their visual systems, e.g. color blindness. The same goes for sound. Air molecules vibrate, but the sound, the experience of a car horn or your friend's voice, only exists when your brain turns those vibrations into something you recognize. So the world you think you live in, it's not really out there. It's happening in here, inside your head. Now take that one step further. A growing number of scientists and philosophers, like cognitive scientist Donald Hoffman, argue that our brains don't just simplify reality, they might completely hide it. His research suggests that evolution doesn't favor accuracy, it favors usefulness. In other words, your senses evolved not to show you the truth, but to keep you alive. Think about it like a computer interface. When you drag a file into the trash on your desktop, you're not literally pushing digital particles into a bin. That's a visual metaphor, a trick to make something complex feel simple. And according to Hoffman, that's exactly what reality is doing to you. Every object, every color, everything you see, just an icon, a user interface, a way of interacting with something vastly more complicated underneath. Something your brain could never truly comprehend. We're not seeing the truth. We're seeing what we need to see in order to survive, in the same way a file icon on your computer screen helps you navigate without understanding all the underlying electrical signals. That sounds wild, but it lines up with quantum mechanics too. When we look at particles, electrons, photons, quarks, we find that they don't behave like little marbles or balls. They don't even exist in one place at one time. Until you measure them, they're not anywhere. They're smeared across probabilities. And when you do observe them, they collapse into something real, as if the very act of observation pulls reality into existence. So, what's more likely? That there's a neat, solid, objective universe out there, but it just happens to look totally different whenever we zoom in. Or that the solidity is the illusion, and the strange, observer-dependent quantum world is the real one. Now combine that with Hoffman's idea. If your senses evolved to give you a simplified interface, and if quantum physics says things don't exist until they're observed, then maybe what we call reality is more like a dashboard, something that keeps you alive and functional, but tells you nothing about what's really going on. In fact, Hoffman's team ran mathematical simulations, showing that agents who saw the world as it really is lost, every time. They were outcompeted, out-evolved, and wiped out. The winners, the ones who saw none of the truth, only the useful shortcuts. So what if this table isn't solid? What if your phone isn't really there? What if the stars, the sky, your hands, your voice are just front-end visuals for a back-end system that's nothing like what you think? That's not just metaphor, it might be physics. Even the idea of things existing in space falls apart under scrutiny. What we call objects, chairs, atoms, even people, are not actually discrete entities. They're temporary configurations of energy, structured by invisible laws. There's no sharp boundary between you and the world. You're not a sealed unit. You're part of a system, a process, constantly exchanging particles, energy, and information with everything around you. You breathe in atoms that were once part of other people. The carbon in your body was forged in stars, and at the quantum level, the difference between you and not you becomes fuzzy, undefined. So, if your brain shows you a simplified world, and that world is made of objects that aren't really objects, and those objects behave like ghosts until they're observed, then how real is any of this? That's the illusion of physical reality. Not that nothing exists, but that what you think exists isn't what's really there. What's really there might not be made of matter or space or time. It might not be things at all. It might be patterns, relationships, or raw information, shaped by perception, filtered by brains, and interpreted by consciousness. And here's the kicker. If no one's observing it, and there's no solid thing to observe anyway, then what's left? Maybe the universe we think we're living in, the one with stars and atoms and galaxies, is just the interface. And maybe behind that interface is something so strange, so unfamiliar, that calling it a universe at all might be the biggest illusion of all. If you ask most physicists when they first started doubting reality, the answer usually comes back to the same thing: quantum mechanics. It's the theory that changed everything. Not because it added new details to our picture of the universe, but because it completely rewrote the picture itself. It didn't just tweak the laws of nature. It made us question whether nature has laws in the first place, or if what we call laws are just patterns that only emerge when we're watching. At its heart, quantum mechanics is a set of rules that describe how the tiniest pieces of the universe behave. Electrons, photons, neutrinos, the basic ingredients of matter and energy. But when physicists began observing these particles closely, something bizarre kept happening. They refused to act like objects. Particles didn't move in clean paths. They didn't sit in one place. They didn't have definite properties. Instead, they seemed to exist in a haze of probabilities. Not in one state, but in many. Not in one location, but in multiple. Not as definite things, but as possibilities. The only time they decided to be anywhere or do anything was when someone measured them. And that's where everything started to unravel. Take the classic example, the double-slit experiment. Fire individual particles, like electrons at a screen with two slits, and they somehow create an interference pattern. Not two clusters like you'd expect if the particles just flew through one slit or the other, but a wave pattern, like the particles went through both slits at once and interfered with themselves. That makes no sense, unless you stop thinking of the electron as a particle and start thinking of it as something more abstract. A wave of potential outcomes. Now here's where it gets weirder. Add a detector, a simple measurement device to check which slit the electron goes through, and suddenly the interference pattern disappears. The particle chooses a path. It behaves like a single particle again. The act of observing it changes the outcome, and not just in a vague, poetic way. It literally changes what the electron does. So, what's real here? The particle, the measurement, the pattern, or just your choice to look? Physicists tried to explain this away. Some said the wave function, the math describing those possibilities, was just a tool for prediction, not a real thing. Others weren't so sure, because the math worked too well. It wasn't just useful, it was precise. It predicted outcomes with accuracy no other theory ever matched. So maybe the wave function wasn't just a trick. Maybe it really was the thing, in which case the universe at its core isn't made of particles or matter, but of probability. That's not speculation. That's the backbone of modern quantum theory. When you calculate what an electron will do, you don't get a position. You get a wave function, a spread of outcomes. You don't get one answer. You get a cloud of potential answers. And it's only when you make a measurement that one of those outcomes becomes real. But what does that mean? That there wasn't an electron until you looked. That it had no position until you asked the question. Some physicists tried to avoid this by introducing hidden variables, invisible properties that the particle really had, but we just couldn't see. The problem? Those theories got destroyed by actual experiments. In the 1960s, physicist John Bell came up with a test, a way to check whether reality was hiding some deeper layer underneath quantum mechanics. When those tests were finally run, in labs across the world, they all pointed to the same uncomfortable conclusion. The universe doesn't work the way we think. There are no hidden variables. There's no deeper layer where particles are just waiting to be discovered. What we see is all there is, and it only shows up when we look. This is known as Bell's theorem, and its implications are brutal. It tells us that either information can travel faster than light, which breaks relativity, or that reality isn't real unless it's observed. You have to choose. And neither option feels right. Now bring in another experiment. The delayed choice quantum eraser, first proposed by John Wheeler in the 1970s and experimentally realized in the 1990s. This one takes things even further. In this setup, you fire a particle at a double-slit screen, but wait to decide whether or not to measure it, after it's already gone through the slits. And somehow, depending on whether you choose to look or not, the particle behaves retroactively, as if your choice in the present changed its behavior in the past. It's not a metaphor. That's what the data shows. The future influences the past. The act of measurement doesn't just reveal the outcome. It seems to determine what the outcome was all along. This throws everything off balance, because it means that time isn't what we thought it was. That cause and effect are blurry, that the arrow of time, past to future, might not be fundamental at all. And this is where things begin to collapse, not just particles, but the very idea of the universe being there in any classical sense. Because when you zoom in far enough, there's no thing to find. No little nugget of matter sitting in space, doing its own thing, waiting for us to discover it. Instead, you get a system that behaves more like a question than an answer. A shifting cloud of probabilities, outcomes, and relations, shaped by what you ask, when you ask it, and how you look. A universe that doesn't show its face until you demand it to. And even then, the face you see is just one possibility among many. A snapshot frozen out of a sea of maybe. So when physicists say the universe might not exist, they don't mean it's all a dream. They mean that the things we thought were out there, fixed, absolute, independent of us, might not exist at all. Not as we imagined. Not as solid things, but as uncertain processes that only cohere into something real when we interact with them. This isn't science fiction. This is the standard interpretation of the most successful scientific theory ever created. And the deeper you go, the worse it gets. Because if particles don't have positions, and reality depends on measurement, and time can be influenced from the future, then the entire framework of space, time, and matter might be a kind of illusion. A working interface, a functional model, but not something real in the way we've always assumed. Which raises a strange question. If the universe behaves more like information than stuff, then maybe what we're living in isn't a universe at all. Maybe it's a computation, a calculation, a system of relationships playing out across invisible rules. And maybe the thing we've always called reality is just the output of a much deeper process, one we're only now beginning to glimpse. By now, we've seen that space might not be fundamental. That time might be emergent. That matter itself could be nothing more than fluctuations in invisible fields. We've seen that the universe, everything we take as concrete, could be the result of deeper rules, entangled structures, and information flow. And that raises a question we can't ignore anymore. If all of this can be described in terms of data, rules, and computation, then is it possible that the universe is a computation? Let's be clear. We're not talking about the pop culture version of simulation theory, where aliens built a matrix, or we're stuck in a video game designed by future humans. That's the flashy version, easy to imagine, but not what serious physics is pointing toward. This is something deeper, stranger. The idea that reality behaves so much like a computational process that it might be one, not running on a computer, but indistinguishable from one in structure and function. The simulation doesn't have to be created to be real. It only needs to work like a system of logic. Let's back up. In the early 2000s, philosopher Nick Bostrom framed a now famous argument. He said that if advanced civilizations can simulate conscious beings, and if they have any interest in doing so, then simulated realities would vastly outnumber real ones. In that case, the odds that we're in the base reality are low. But we're not here for philosophy, we're here for physics. And physics is starting to reveal patterns that make this idea hard to ignore. First, digital behavior. At small scales, nature isn't continuous, it's quantized. Energy comes in packets, spin comes in fixed values. Even space, if theories like loop quantum gravity are right, comes in finite chunks, like pixels. That's not how analog systems behave, that's how digital systems behave. Second, universality of rules. Every interaction we've observed, from gravity to electromagnetism to nuclear decay, follows precise mathematical patterns. Not approximately. Exactly. This doesn't just make nature predictable, it makes it programmable. The entire universe seems to be running on code, not metaphorical code. Literal, rule-based interactions that take inputs and return outputs. Third, limits of information. Black holes again show us something weird. According to the Bekenstein bound, the maximum amount of information that can be stored in a region of space is proportional to the surface area, not the volume. That means there's a cap on how much information any region of the universe can contain, and if there's a cap, there's a resolution, a data budget, like memory on a hard drive. This fits with the holographic principle. It also fits with the idea that the universe might operate like a computational system, finite in information, rule-governed and bounded. But here's the part that really matters: reversibility and logical consistency. In computation, every step follows from the last. There's a chain of operations, and each outcome is determined by the rules of the system. In classical mechanics, this was true too. The future followed from the present. But quantum mechanics broke that, unless you zoom out. In many interpretations, including the many worlds interpretation, the quantum universe evolves deterministically at the global level. All possible outcomes are encoded. Nothing is erased. That's exactly how a reversible computation works. Nothing is lost. Every possibility is preserved. The randomness only appears when you observe from within. Just like a subroutine inside a program doesn't see the rest of the code running in parallel. So what if our entire universe is a kind of recursive computation? Not simulated in the way a game is simulated, but emergent from rules that generate structure out of initial conditions. That's where the work of physicist Stephen Wolfram becomes relevant. In his book A New Kind of Science, and more recently in his physics project, he suggests that the universe is not a machine running equations. It is the equations. That everything, space-time, particles, causality, can emerge from the evolution of simple rewriting rules applied to abstract objects like hypergraphs. These aren't spatial objects. They're patterns of connections. And by letting these patterns evolve through discrete steps, Wolfram's models generate systems that display behavior eerily similar to what we see in physics: relativity, quantum interference, locality, and even conservation laws. This isn't proof, but it's a sign. A sign that maybe we've been looking at reality backwards, not as a structure existing in space and time, but as the output of computations that generate the illusion of space and time. And that ties into Max Tegmark's mathematical universe hypothesis. Tegmark's idea is simple but radical. The universe isn't described by math. It is math. It's not that equations model reality. Equations are reality. If something is logically consistent and mathematically well-defined, then it exists, and our universe is just one such structure. In that view, we're not living in a simulation built by someone. We're part of a mathematical object, like the Mandelbrot set or a cellular automaton, existing eternally as a logical possibility. There's no need for a program, no need for a computer, just the rules. But if that's the case, then what does it mean to exist? Because in a computational universe, everything is just a state in a system. The chair, the tree, the moon, they're not objects floating in space. They're states in a gigantic logical operation. They're patterns that persist because the rules make them persist. You and I are like stable loops in a program, self-reinforcing data structures held together by feedback and flow. So we have to ask, is there a universe outside the rules? Or are the rules all there is? If this view is right, then reality isn't some grand cosmic machine humming away in a void. It's the totality of consistent relationships. A closed set of self-consistent operations, unfolding step by step, without a background, without a container, and without an observer outside the system. Which means there's no universe to find, no physical object labeled reality, just the rules, just the logic, just the information evolving. And from that, everything else arises. So far, we've taken apart the physical world piece by piece, matter, particles, space, time, and found that none of it holds up the way we thought. It's not made of objects in space. It's not built on steady ground. It's not even there in the traditional sense. Instead, it's all pattern, structure, relation, and information. But there's one thing we haven't touched yet. The observer, not the telescope, not the detector, the experience behind the observation. The fact that there's a point of view, a conscious witness. And here's where things get uncomfortable. Not because it's spiritual or vague, but because physics has been quietly tiptoeing around this issue for almost 100 years. And it still doesn't know what to do with it. Let's go back to quantum mechanics, specifically the measurement problem. When you observe a quantum system, you get a definite result. But before that observation, the system exists as a wave function, a superposition of possibilities. The math describes probabilities, not certainties. So, how does a specific outcome appear? What turns that cloud of maybes into a single event? Some interpretations say the wave function isn't real. It's just a tool for predicting outcomes. But others, like the Copenhagen interpretation, suggest the wave function does represent something real, and that the act of observation collapses it. So, what counts as an observation? A screen, a detector, a thermometer? In most setups, measurement devices are treated as classical, that is, not quantum themselves. But everything is quantum, right? Detectors are made of atoms. So are brains. So at what point does the wave function collapse? Where's the line between quantum and classical? And here's where things get interesting. There's no clear answer. You can push the boundary further and further, automate the detector, the analysis, the logging, and the system stays quantum. The only place where things get definitively real is at the level of conscious awareness. At the moment a result is known. That doesn't mean your thoughts are collapsing wave functions. It means there's a missing piece, a gap between the equations and the experience, between the math and the moment. This is sometimes referred to as the Heisenberg cut. the line between the quantum system and the observer. But that line is arbitrary. Move it wherever you want and the math still works. That's not a bug. That's the problem. Physicist Eugene Wigner went even further. He argued that consciousness must be fundamental to the measurement process, that wave function collapse doesn't happen until a conscious observer sees the result. To test this, he imagined the now famous Wigner's friend thought experiment. It goes like this. Your friend is inside a sealed laboratory, performing a quantum experiment, say measuring the spin of an electron. From their point of view, as soon as they observe the result, the wave function collapses into a definite state, either spin up or spin down. The outcome becomes real for them. But from your perspective, standing outside the lab, you have no idea what result your friend saw. As long as the lab remains closed and isolated, quantum theory says you must treat the entire lab, your friend included, as being in a superposition. One in which they saw spin up, outcome A, and one in which they saw spin down, outcome B. According to standard quantum rules, until you open the door and ask your friend what they saw, both outcomes coexist in parallel. It's as if your friend is in two states, having seen outcome A and having seen outcome B. So, who is right? Did the collapse occur when your friend saw the result, or only when you became aware of their experience? Wigner's thought experiment poses a profound challenge to our understanding of reality. It raises the unsettling possibility that conscious observation may not just witness reality, but may be necessary to create it. The moment of collapse may not happen until an awareness emerges to register it. While this idea may seem absurd, it's not a joke. These kinds of scenarios are being taken seriously now, not because they point to mystical truths, but because they reveal cracks in the foundations of physics. One possible conclusion is that consciousness plays an active role in reality, not in a magical way, but as an essential ingredient. Maybe reality isn't something that exists independently, out there, waiting to be discovered. Maybe it's something that emerges at the intersection of the observer and the observed, a process, a co-creation. This idea has resurfaced in modern contexts. For example, the participatory universe model, proposed by physicist John Wheeler, suggests that the universe requires observers to exist in any meaningful way. That what we call reality is incomplete without observation. And that observation isn't passive, but constructive. Wheeler famously said, "No phenomenon is a real phenomenon until it is an observed phenomenon." That suggests the universe doesn't simply exist and wait for us to notice it. Rather, the act of noticing is part of what makes the universe real. Again, this isn't about beliefs or metaphysics. It's about accounting for what physics actually predicts and what we actually experience. There's also growing interest in integrated information theory, IIT, which attempts to quantify consciousness in terms of information structure. It proposes that consciousness arises when a system contains a high level of integrated information, a kind of feedback loop where the whole is more than the sum of its parts. If true, then consciousness is not tied to a brain or biology, but to a particular kind of structure, a pattern, which would mean consciousness might be fundamental to the universe, not an afterthought, but part of the base-level architecture. And if that's the case, we may need to flip the question entirely. Instead of asking, how does consciousness emerge from the universe? We might need to ask, how does the universe emerge from consciousness? That's the direction explored by analytic idealism, where the physical world is seen not as primary, but as a shared interface between conscious agents. A kind of public space, generated by overlapping experiences. It's not mainstream physics, but it's becoming harder to ignore, especially as the role of the observer refuses to be explained away. Even in the most conservative models, the fact remains. There is experience, there is subjectivity, there is observation. And physics still doesn't know where to put that. You can describe particles, fields, symmetries, and dynamics, but none of that explains why you're aware of them. None of it predicts the first-person experience of being anything. There's nothing in the Schrödinger equation that implies the color red or the taste of salt or the sound of your name, yet here you are. So, what happens when you build a model of the universe that accounts for everything, except the fact that someone is looking at it? You get a complete map with no territory, a system with no context, a machine running perfectly, but with no one home. That's why some physicists are beginning to admit, maybe the one thing we've treated as least important, awareness, is the only thing we're sure exists. And if the universe doesn't exist apart from observation, then what is it? Maybe not a place, not a thing, not a structure. Maybe it's a conversation, a moment-by-moment act of interpretation, a live rendering of what's possible, collapsing into what's perceived. And if that's the case, then the universe doesn't precede consciousness. It follows it. So far, we've torn apart the model of the universe piece by piece. We've seen matter reduced to excitations, space demoted to a side effect, and time turned into a statistical illusion. The idea of a thing out there, solid, objective, persistent, has evaporated under the weight of physics itself. But if the universe isn't real in the way we thought, then what does that make us? You'd think this would be the easier part. After all, if nothing else, you exist. You're here, thinking, watching, aware of something, even if you're not sure what it is. But that certainty too begins to shake when we look closer. What are you? A body? A brain? A process? Are you a pattern of neural activity, playing out according to rules you didn't choose? Are you a system of thoughts and behaviors shaped by genes, culture, and experience? Or are you something else? The one who sees it all happening, but isn't part of it. In a universe that no longer contains absolute space, permanent objects, or a reliable flow of time, the idea of a self becomes complicated. Let's start with the body. It feels like your anchor, the part of you that's real. But modern biology paints a different picture. Your body is not a static structure. It's a living process. Your cells are constantly dying and regenerating. Your atoms are replaced over and over. The body you had 10 years ago, it's physically gone. And yet, you feel like the same person. So if the you isn't in the flesh, where is it? Maybe the mind. But the mind too is slippery. It's not a single thing. It's a stream. Thoughts rise and fall. Memories come and go. You forget things, invent false ones, and change your opinions over time. The mental self is fluid, unstable, a narrative that rewrites itself as it goes. Some might say consciousness is the answer, the fact that you're aware. But what is consciousness? It's not intelligence. Intelligence can be mimicked by algorithms crunching data, solving problems, or playing chess without ever feeling a thing. It's not memory either. Memories are just stored information, retrievable by neurons or hard drives alike. It's not a thing. You can't locate it, measure it, or describe it in physical terms. There's no equation for it, no coordinates. It doesn't occupy space. It doesn't obey any known force. Yet it's the one thing you cannot deny. You might doubt the world. You might doubt your beliefs. But you can't doubt that you're experiencing something. It's the raw experience of being, the feeling of red, the sound of a violin, the sting of regret. This is the hard part of the hard problem of consciousness. Not how neurons create thoughts, but how subjective experience exists at all. You can reduce everything else to function, inputs, outputs, behavior. But experience doesn't fit. There's no clear way to explain why red looks like red, or why pain feels like pain. You can describe the brain states, you can even replicate them. But the experience, the qualia, can't be predicted from the data. This opens the door to something strange. Maybe we've had it backwards. Maybe experience isn't a product of the universe. Maybe the universe is a product of experience. That's not just a philosophical fantasy. It's an idea that's been quietly spreading across multiple disciplines. from neuroscience to quantum physics to computational theory. The growing suspicion is that what we call reality might not be primary, that it might be a constructed interface emerging from some underlying process of observation or interpretation. In this model, the self isn't something living inside the universe. It's part of the system that gives the universe shape. Not a controller, not a creator, but a participant. In some interpretations, the self is not even a thing. It's a boundary, a line drawn between what is known and what is not, between what can be experienced directly and what must be inferred. In this view, you are not a noun. You're a verb, a function, a frame of reference through which information collapses into reality. That sounds abstract, but it's not. When you perceive something, anything, you're creating meaning, not inventing it out of nowhere, but reducing ambiguity, choosing a version, a configuration. What you see, what you hear, even what you think is never raw data. It's always interpreted, selected, rendered. This matches what physics has been saying all along. Outcomes aren't fixed until they're observed. And observation isn't passive, it's participatory. So where does that leave you? Maybe you're not inside the universe at all. Maybe you are the mechanism by which the universe appears. Not as a separate observer, but as a local process. A temporary fold in the structure that happens to reflect itself. This is the idea behind participatory realism, a philosophical perspective advanced by American physicist Christopher A. Fuchs. He proposes that reality doesn't exist out there, but only arises through interaction. You don't observe the universe. You are one of the interactions that gives it form. This challenges the classical notion of a fixed external world. This idea resonates with ancient philosophies, reinterpreted through a scientific lens. It echoes Buddhism's no-self, where the self is not a fixed entity, but a process of interdependent interactions. It inverts Descartes' doubt, shifting from "I think, therefore I am" to a reality defined by participatory engagement rather than isolated certainty. Similarly, it parallels Hinduism's Atman-Brahman unity, where individual consciousness and universal reality are intertwined. Yet Fuchs grounds this in quantum theory's empirical limits, not spiritual metaphor. Modern science's inability to pin down an objective, observer-independent world leads to this logical conclusion. Reality is relational, arising through our interactions with it. And this has one more consequence. If the universe is informational, and we are embedded perspectives within that information, then the idea of a singular global reality breaks down. Each observer doesn't just see the world differently. They might see a different world. Not because they're hallucinating, but because reality itself is fragmented, distributed, relational. This brings us to the strange but increasingly supported view that there is no single shared universe, just overlapping domains of information, coherently interacting, each forming its own version of events. You're not a thing in a world, you're a perspective in a structure. And if that structure changes depending on who's looking, then the universe doesn't contain independent observers. It's made of acts of observation, which makes the self, the very thing we thought was separate from reality, the last piece left standing. Not because it's fundamental, not because it's supernatural, but because it's the one feature that can't be removed without collapsing the entire system. The self emerges as the linchpin of existence, because it is inseparable from the act of experiencing. The self is the fulcrum upon which the universe pivots, the irreducible spark that ignites reality. You can remove matter, and the cosmos might still hum with energy. You can remove time, and patterns might persist in some eternal now. You can remove space, and relations might endure in an abstract web. But you can't remove the experiencer, because without experience, there's nothing to talk about, nothing to measure, nothing to collapse, no physics, no theory, no world. Just a blank. So the question isn't, what are we in, or what are we made of? These are echoes of a materialist dream, a yearning for solid ground. The real question is far more urgent, far more alive. What are we doing right now that breathes existence into being? Every thought, every sensation, every choice is an act of creation, a fleeting collaboration with the universe. You are not just in reality. You are its co-author, its pulse, its possibility. To live is to observe, and to observe is to make real. After everything we've broken down, the unreliability of space, the instability of matter, the illusion of time, and the dependency of reality on the observer, there's a deeper question emerging underneath it all. Have we been chasing something that doesn't actually exist? Not in the mystical sense, not in the nothing is real cliché, but in a very technical, very concrete way. That the idea of a single, objective, background universe might be a projection of our thinking, a misunderstanding of how reality is structured. We've spent centuries trying to describe the universe as a container, as a place that holds things, a setting, a map. But what if there was never a there to begin with? That's not just philosophical speculation. It's a natural conclusion when you trace modern physics to its edges. Because the more precisely we try to define where something is, the more space itself starts to slip away. The more we try to isolate what something is, the more its identity dissolves into relationships. We keep chasing structure, but when we get close, the structure collapses into context, into reference points, into comparisons, never absolutes. Take particles, for instance. We used to think they had position, momentum, mass, and charge, properties you could list and pin down. But now we know these properties only make sense relative to other things. A particle has a momentum with respect to a frame, an energy with respect to a system, entanglement with respect to a measuring device. None of these properties are standalone. They don't exist independently. They exist in relation, which means that if you try to isolate one thing and ask, what is it? You're missing the point, because nothing exists on its own. This is where physics begins to look like language. You can't define a word without using other words. You can't explain a concept without referring to other concepts. Meaning is built on difference, not substance, not essence, just relationships. And the universe seems to behave the same way. There's no absolute grid, no external reference. Every coordinate, every quantity, every measurement only makes sense in terms of something else. And if everything is defined this way, not as a thing, but as a position within a web of relations, then what exactly is the universe we've been trying to describe? It might be that what we call the universe is just a model, a framework that works well within a narrow range of scales, but doesn't exist beyond it, like Newtonian mechanics. It's useful, it works, but it's not fundamental. It's not the real thing. It's the version that happens to emerge under certain conditions. And if that's true for space, time, mass, and motion, then maybe it's true for the entire concept of a universe. That's what theories like relational quantum mechanics proposed by Carlo Rovelli are starting to suggest outright. That there is no global reality, no complete view, just interacting perspectives, each defining their own local reality. There's no universal truth to collapse the wave function for all observers. Each system collapses its own version according to its own interactions. In other words, there's no there, there's only the act of interacting, the event, the relation. Reality in this view is not a thing we live inside. It's the sum total of what's happening between systems. This echoes something that's shown up in multiple areas of physics. In quantum field theory, particles aren't real. Fields aren't even real in the old sense. They're just bookkeeping devices, tools that encode how different systems influence each other. What's physically meaningful isn't the field or the particle or the wave function. It's the correlation between inputs and outputs. In general relativity, space-time isn't a grid. It's a record of how objects influence each other's paths. Curvature isn't a thing that exists by itself. It's what you see when masses shift relative to each other. Again, relationships, not things. And in thermodynamics, entropy isn't a substance. It's a measure of uncertainty. It tells you how many possible configurations your system could be in, given what you know. It's not about the thing itself, it's about your information about the thing. So, over and over, the pattern is clear. What we call real is really shorthand for a set of relationships, a structure of differences, a pattern of outcomes. There's no core, no center, just interaction. And if everything reduces to interaction, then there's no need for a background, no need for a canvas, because the painting is only the brushstrokes. There is no surface underneath. So maybe what physics is trying to tell us, without quite saying it, is that the universe isn't a thing at all. It's not a system with parts. It's not a location. It's not a container full of matter governed by laws. It's a process, a set of ongoing transformations, not from one state to another, but from no state to something observable, again and again. Not because there's a hidden structure pushing things forward, but because forward is what the system looks like from the inside. You were never inside the universe. You were always inside a particular version of the story the data tells when it passes through a perspective like yours. So, what is the universe? Maybe it's not a place. Maybe it's the word we use to describe the patterns that show up when nothing becomes something, through the lens of something else. By now, the idea of the universe as a physical thing, a giant machine, or a place filled with objects, is long gone. What we've been left with is a system of relations, a layered mesh of interactions, correlations, and outcomes. No objects, just structures, no timeline, just informational flow, no definite states, just probabilities collapsing into moments. Which leads us to a strange but necessary question. If the universe is just structure, just syntax, then where's the meaning? Because that's what we've been trying to find all along, isn't it? Not just patterns, not just formulas, but something behind it, something in it, a message, a cause, a reason for why anything is the way it is. Something we could point to and say, there, that's what it's all about. But what if there's nothing there to find? What if what we call reality is more like a language, full of rules, grammar, and logic, but with no speaker, no message, no intent, just syntax generating syntax? A recursive system unfolding from initial conditions, with no goal, no observer, and no meaning other than the patterns it produces. Let's break that down. Everywhere we look in physics, we find structure. Not arbitrary chaos, not randomness, but deep order. Elegant equations, symmetries, invariances, conservation laws. It's tempting to believe that such structure must mean something, that it must be pointing to something else. But structure doesn't need meaning to exist. It just needs consistency. Grammar, for example, can exist without anyone speaking. It's a framework. A set of constraints that shape what's allowed and what isn't. The universe behaves in a similar way. It seems to say only what it's allowed to say, based on its internal rules. No equation in physics tells us why things are the way they are. They just tell us what's possible, what's consistent, what follows from what. And that's the difference between syntax and semantics. Syntax is form, structure, the shape of logic. It's what mathematics gives us. Semantics is meaning, interpretation, understanding, purpose. Physics has mastered the syntax, but it has nothing to say about the semantics. The equations don't come with explanations. The patterns don't tell you why they're there. Even the laws of nature might not be laws in the traditional sense. They might not be commands or instructions. They might just be the statistical regularities that emerge from systems large enough to show patterns. Not rules written into the cosmos, just the behavior that becomes inevitable once enough bits interact. Think about Game of Life, devised by mathematician John Conway in 1970. A simple grid-based system where each cell turns on or off based on a few local rules. There's no intelligence behind it, no message. Yet from these tiny rules, enormous complexity emerges. Gliders, replicators, self-organizing patterns. From syntax alone, behavior arises. But there's no meaning in it. No speaker, no listener. Just rules playing out over and over. And maybe that's what our universe is. A kind of cosmic game of life, running on rules we didn't choose, generating structures that seem familiar. Particles, fields, galaxies, minds, but with no deeper purpose underneath. No grand message, no final point. Just information, updating itself. In fact, many of the weirdest paradoxes in physics disappear if you drop the demand for meaning. The wave function collapse. That's not a mystical moment. It's a shift in informational configuration. Entanglement. Not a message sent across space, just a correlated outcome. The Big Bang. Not an event with a purpose, just the lowest energy state that led to the structure we now call history. In this light, the universe stops being a thing. It becomes a process, a set of recursive transformations, each one consistent with the last, each one shaped by the logical structure of what came before. This also fits with what we now believe about mathematics. For a long time, we thought math was invented, a tool we use to describe the world. Then we thought maybe it was discovered, something that existed independently, waiting to be found. But now, it looks like math might be something even stranger, a language of consistency, a way to describe what must follow, given certain starting points. And physics, at its core, is just math plus observation. But if the math is structure, and the observation is local and relational, then what we call the universe might be nothing more than the consistent unfolding of logical relations. A giant expression of constraint, a pattern that can't help but generate itself. And if that's true, then we're not missing the meaning. There never was any. Not because life is meaningless, not because reality is bleak, but because meaning is a human overlay. A product of minds built to interpret, predict, and survive. Meaning is a biological function. It's not written into the structure. It's written into us. That's not depressing. It's freeing. Because it means we stop looking for the meaning and start looking at the structure itself, not as a message from someone else, but as the raw, unfiltered unfolding of what's possible. A system that doesn't pretend to be more than it is. And here's the last strange twist. If the universe really is a language without a speaker, then maybe the speaker is the illusion. The idea that something must be behind it all, that someone had to press go, might just be a leftover from how our brains evolved. We find faces in clouds, shapes in constellations, meaning in coincidences. And when we look at something as big and mysterious as the universe, our brains almost want to personify it to give it character. We personify the impersonal. We imagine intent in the random. We're pattern recognizers. We're storytellers. We see agency where there is none. We assign voices to silence. But maybe the silence is all there is. Maybe the universe is not waiting to be understood. It's just happening. Over and over, in every interaction, in every moment, in every observation. A sentence that rewrites itself forever. We've taken the universe apart, layer by layer, assumption by assumption. We've let go of space. Not a background, not a container, just entanglement. We've let go of time, not a flow, not a ticking clock, just change encoded in relationships. We've let go of particles, waves, matter, just fields, then patterns, then probabilities, then something even less, pure information. And even that started to look like syntax, not substance. So, what's left? If you keep peeling everything back, does anything actually remain? That's the uncomfortable part. Because there's a difference between saying nothing exists the way we thought and saying nothing exists at all. The first is about interpretation. The second is about presence. One reframes reality. The other questions whether there's anything there to reframe. Let's not rush past that. Because at a certain point, when all you've got are logical relationships unfolding through a system with no observer, no space, no time, no objects, you're left with a strange silence. No foundation, no ground, not even emptiness, because emptiness still assumes something to be empty. This is where physics fades into something quieter, not mysticism, not speculation, just the limits of knowing, the outer edge of where explanation can go. What does it mean for something to exist anyway? In daily life, it's simple. If something can be seen, touched, measured, it exists. But everything we've explored here calls that logic into question. We've seen that particles don't have properties until they're observed, that fields aren't located in space, they define space. That outcomes only emerge in context. That meaning doesn't live in things. It arises through interpretation. Even identity, both of objects and selves, turns out to be relational, not absolute. So, what's the status of anything that's left? Maybe there isn't a final layer, no indivisible core, just a system with no bottom, rules built on rules, interactions nested inside interactions, until the need for a thing at the center vanishes entirely. And maybe that's not a failure. Maybe that is the answer. That there is no ultimate stuff, no base reality, just structure, holding itself up. It's like a dictionary where every word is defined in terms of other words, no first term. Just endless mutual definition. It works, it functions. But try to find the one word that holds all the others in place and you won't find it. Because that's not how the system works. It's stable, not because it has a foundation, but because of how all the parts fit together. That might be what reality is. Self-consistent, but not self-explanatory. Not because we don't understand it yet, but because explanation itself breaks down at the edge of recursion. At some point, the need to define things in terms of more fundamental things stops being productive. The system loops back on itself, and all that's left is the loop. So, do we exist? Not in the way we usually think. Not as standalone entities, not as souls trapped in bodies, not as permanent structures with internal essence. But maybe we exist as nodes in the loop, as temporary closures in the structure, as centers of coherence that come into focus when the system intersects with itself in just the right way. We exist as part of the pattern, not outside it, not watching it, as it, not apart from the universe, but not inside it either. Because inside assumes the universe is a thing, and we've already let that go. So what's left isn't the universe. What's left is the unfolding, the process, the happening, the appearance of reality, not in space, not in time, but in the form of relational consistency that for a moment forms a pattern stable enough to call you, or me, or here. And that's not nothing. That's not a failure to exist. It's just a different kind of existence than we thought. Not as matter, not as mind, not even as information in the usual sense, but as temporary coherence, the momentary stability of a pattern that wasn't guaranteed, but happened anyway. Not because it was meant to, not because something wanted it, but because this is one of the ways the structure can fold in on itself and reveal a version of itself that feels like something. And for that version, the one reading this right now, existence is happening. No more, no less. We've followed the path all the way down, removed the structures, stripped the labels, watched the universe dissolve into patterns, and the patterns dissolve into processes. Everything familiar has fallen away. But even now, there's one assumption left standing. We still assume that something had to exist. Not because we have proof, but because we're here. Because experience is happening, and that fact seems to demand something real beneath it. Some foundation, some substance, some presence. But maybe that's the final illusion. Maybe nothing, not just as an absence of stuff, but as a concept, is the only stable baseline there ever was. This isn't new. Philosophers have asked it for centuries. Why is there something rather than nothing? Why does anything exist at all? And modern physics, in its own strange way, has started asking the same thing. Because when we zoom in far enough, something becomes hard to define, and nothing stops meaning empty. It becomes dynamic, active, full of potential. Take the quantum vacuum, what we used to call empty space. It's not empty. It's a seething ocean of fluctuations. Particles and antiparticles appear and vanish, borrowing energy from nowhere and repaying it before anyone notices. It's unstable, restless. It creates fields. It affects matter. It even helps shape the expansion of the universe. Then there's the idea that the entire cosmos, time, space, and everything in it, could have emerged from a quantum fluctuation in this so-called nothing. No space before, no time before. Just a sudden instability in a timeless, featureless field of potential. But that version of nothing still contains rules, possibilities, physics. So dig deeper. What about true nothing? No fields, no laws, no dimensions. Not even a framework for cause and effect. What would that even mean? It wouldn't look like empty blackness. That's still something. It wouldn't be still or quiet. Those are qualities. It wouldn't be a state, because states can change. It wouldn't be an event, because events imply time. It wouldn't be anything. And here's the strange part. This absolute nothingness might be the most stable thing imaginable. It can't decay. It can't change. It doesn't require explanation, because there's nothing there to be explained. Everything else, space, matter, logic, awareness, is an interruption, a ripple, a brief disturbance in the smoothness of absence. So, what if existence isn't the default? What if it's the exception? And what if that exception, everything we see, feel, and believe, is just one momentary configuration of a system that by all rights shouldn't be here at all? Maybe the reason the universe looks like math isn't because it was designed that way, but because math is the only thing that can arise from absolute nothing without contradiction. Maybe logical structure is the one kind of pattern that doesn't need a background. It just is, or isn't, and if it is, it unfolds. And maybe that unfolding, that first tiniest flicker of difference, is what we call the universe. Not something being built on top of nothing, but nothing reshaping itself into something temporarily. This flips the whole question. Instead of asking why does something exist, maybe we should be asking why would it ever stop? Because once that first pattern appears, once possibility is introduced, it's self-perpetuating. It can reflect, replicate, recombine. Once there's structure, structure can evolve. And maybe there was never a switch. Just the inevitability that if difference is possible, difference will happen. So, the universe might be what nothing looks like when it stutters. Not a place that was created. Not a thing that emerged. Just the absence of absence, catching itself for a moment before fading again. And if that's true, if this whole story we call reality is just a brief fold in the cloth of nothingness, then maybe the reason we can't find anything solid at the bottom is because there isn't anything there. There was never a bottom. Just the echo of zero trying on the shape of one. We began with a simple premise, that maybe physicists are right when they say the universe doesn't exist. And along the way, we didn't find anything solid to hold on to. No fixed space, no consistent time, no independent particles, no objective observer, no ground beneath our feet. Just processes, just patterns, just interactions between things that never quite stand on their own. And slowly, the picture started to shift. Not because reality became more complicated, but because it became thinner, flatter, less about substance, more about structure, less about what is, more about how things relate. Until, at some point, we realized we weren't looking at a universe anymore. Not in the way we used to. We were looking at a system that only appears to be a universe when you ask it the right kind of question. You get shapes, you get rules, you get behavior, but no one's behind the curtain, no core, no secret. Just syntax and the illusion of depth. We wanted to find something real, something that couldn't be reduced, dissolved, or reframed. But every time we thought we had it, it slipped through. It changed form. It turned out to be a shadow cast by something else. And that something else? Another shadow. So maybe the universe, as an idea, as a structure, as a story, is exactly that, a system of illusions, layered so precisely that they become functional, coherent, predictable, real enough to live in, real enough to question, but never quite real in the way we hoped. And that's the point. Because if what we call reality is an illusion, it's not the kind you can wake up from. It's not a trick. It's not a mistake. It's a framework, a process that keeps resolving uncertainty into structure, keeps folding interaction into meaning, keeps turning nothing into something over and over again, without ever stopping to ask why. There's no deeper message, no hidden speaker, no final truth waiting to be uncovered. And maybe that's the clearest picture we've ever had, that the universe isn't real. Not because it's fake, but because it's not a thing at all. It's a behavior, a continuous, recursive, unresolved act of becoming, not of being, not a place, not an object, not even an answer. Just a question that keeps rewriting itself from the inside,